Hi, my name is Julio Miralles, and I will be talking about linear regressions and correlations. Statisticians use regression to predict the value of one variable based on the value of another variable. In this lesson, you will learn how to use regression, when to use regression, and how to assess the quality of regression results. A way in looking at linear regression is by looking at a cause and effect relationship, because it exists when a value of one variable influences the value of another variable. The causal variable is called the independent variable, and the variable that is influenced is the dependent variable. You should only use linear regressions when certain conditions are met. The three very important things you gotta think about: number of variables, measurement scale, linearity. Linear regressions can be used effectively only when the causal relationship consists of one dependent variable and one independent variable. Both variables are measured on an interval or ratio scale of measurement, and another relationship between the dependent variable and independent variable is that they're both linear, rather that they're curvilinear. Consider the relation between IQ and test score. We can use linear regression to predict the test score based on IQ. The relation consists of one dependent variable and one independent variable, so we satisfy the number requirements. Both variables are measured at an interval ratio scale, so the measurement scale requirement is satisfied, and the relationship between variables is roughly linear, so the linearity condition is satisfied. Since all three requirements are met, we can use linear regression to describe the relationship between IQ and test score. The value of a correlation coefficient ranges between -1 and 1. The greater the absolute value of the coefficient, the stronger the linear relationship. So the strongest relationship is indicated by a coefficient equal to -1 or 1. The maximum correlation occurs when the data points fall in exactly a straight line. The weakest relationship is indicated by a coefficient equal to 0. When data points are randomly spaced on the scatter plot, the correlation is weak, or 0. A positive correlation means if one variable gets bigger, the other variable gets bigger as well. On a scatter plot, when data points flow left to right on an upward direction around a straight line, the correlation is positive. A negative correlation means the opposite. If one variable gets bigger, then the other one gets bigger. Then the other variable gets smaller. On the scatter plot, when the data points follow on a straight line that slope downwards from left to right, the correlation is negative.